The next topic to discuss is clustered versus unclustered indexes. This is a property that only applies to by-reference indexes, alternative 2 or alternative 3. And in some sense, this is really more a property of the heap file that the index references, rather than a property of the index itself. A clustered index is one in which the records it references in the heap file are kept, mostly, ordered in the same order as the search keys in the index. Now, this heap file order doesn't have to be perfect. It's just a performance hint that improves things. So it's not actually a sorted file. We'll allow it to be unsorted, but we're going to hope that it's mostly sorted in order. And the cost of retrieving data records through an index varies greatly based on whether it's clustered or not, and sort of how clustered it is. How close is the ordering in the heap file match the ordering in the leaf level of the index? As an aside, there's a definition of something called clustering in AI and machine learning, which is the grouping of nearby items in n space. And that definition of clustering is actually something very different from what we're going to talk about here. So let's focus on clustering as it's used in the context of indexes and databases. So to see this, let's look at a picture. To build a clustered index, the way we're going to do it is first sort the heap file, leaving some free space on each block for future inserts. And then the index entries at the leaves of our index are going to direct search to take us to the data entries in the heap file. So on the left is a picture of a clustered index. On the right is the picture of an unclustered index. And I want you to focus on two important differences between the left and the right. Note that the dotted line is the divider between the index and the heap file. Things below the dotted line are in the heap file. Things above the dotted line are the index. On the left, look at the left 2 pages of the index in the clustered case. Notice that all the pointers on those 2 pages are pointing in order. They don't cross, which means that they're pointing to records that are sequential in the heap file. All right? Whereas on the right, we have this sort of crisscross spaghetti of pointers pointing all over the heap file. Another side effect is that on the left, we're pointing to a total of 3 pages in the heap file because the records we're pointing to are all packed together tightly. On the right, some of the things we're pointing to are on faraway pages, some on near pages, and interspersed with that data are records that are pointed to by other index leaf entries. And so you can see that it takes more heap file pages to satisfy a query on the first 2 index pages on that range than it would in a clustered index. So clustered indexes give us fairly sequential access to data in the heap file because things are kind of contiguous. And they also give us lots of bang for our buck on every I/O. When you do an I/O in the heap file, in the clustered case, most or all of the data we fetched from the heap file is data we wanted for the index. On the right, when we fetch a heap file page, we're getting data that was relevant to maybe index leaf nodes that are far away from our query. Now, how do we deal with insertion in a clustered index? Remember I said it does not have to be a perfectly sorted file. And so when you have an insertion into a clustered index, that insertion is probably going to go down to the leaf level of the index, but then we're going to need to put it in the heap file. And in the heap file, if we're lucky, it'll fit on the heap file page at the bottom of the index that we point to. But if we're not lucky, we'll simply have to allocate another block at the end of the file. And we'll have a pointer at the leaf level of this index far away to that new block at the end of the file. And in a clustered index over time, this will happen. You'll have some of the pointers at the leaf level of the index that are just pointing off to strange places in the heap file. And from a correctness perspective, this is totally fine. The index continues to work. If you have lots of inserts, over time the clustering kind of breaks down, and the heap file is no longer mostly in sorted order. It's kind of not very much in sorted order. In that case, if you want to recluster the index, what that means is resorting the heap file in the order of the index and storing it back on disk in sorted order. And you can do that. So clustered indexes are much faster. They're fewer I/Os and they're sequential I/Os for range queries. But clustered indexes are not a correctness issue. As the index becomes unclustered through inserts, it's a performance degradation, but it's not a correctness problem. So to summarize, clustered index pros, they're particularly efficient for range searches because as we saw in the queries previously, it's when you're looking at multiple pointers at the leaf level of the index that you get the benefit of clustering. So they're particularly good for range searches. They give you locality benefits because the heap file accesses are sequential, which allows us to do prefetching and all that good stuff for range queries. Clustered indexes will also support certain types of compression, and we'll see more about key compression in just a moment. There are some cons to clustered indexes. They're more expensive to maintain. After we get a whole bunch of insertions, we may need to periodically resort the heap file and update its order. A solution to this is to sort of lazily in the background, as you're seeing some insertions come in, resort little bits of the heap file, maybe scoot some things around to make it a little more sorted. And so in sort of high performance advanced database systems, you might have background tasks that are reclustering the heap file incrementally rather than doing a big sort and restore. Another thing to keep in mind is if you want this to work pretty well, you try to keep your heap files not too densely packed, maybe 2/3 packed on the heap file pages, to leave plenty of room for future insertions and for sort of fiddling with the order over time.